So this is part 9 in the series on how to show video on the Commander X16. Let's just have a quick look at what we've done. Everything with a check mark is done. And everything in green is what we're going to do in this video. We're going to write some initialization subroutines and finalization subroutines. And then we are going to write a subroutine that converts the palettes and images for all the frames in our video. So let's get started. We've loaded that up already, and I've done a bunch of programming here already. One of the things, here's a cat C. This converts the accumulator to 2 hex characters and stores those in X and Y. We're going to be using that a little bit later. I've added this here, SCAL. It is just a single byte. All I'm going to do is read from Vera. We're going to go and look at the, where are we here? The DC horizontal scale. We're going to look at the active display horizontal scale, and we're just going to store that here at the very start. So we're going to be changing the horizontal scale to 2.0, but at the end we're going to change it back. So that's what I'm saving this for here. So next we want some initialization routines. Well, let's go to GoGo. Now this is our initialization routines. If we go look at our plan here for today, we've only got to write a couple routines here. We got to write an initialization routine for Vera. We got to write a finalization subroutine for Vera that puts everything back where it was, and we got to write a short subroutine that sets tile 0 to all zeros. Other than that, we've already got our initialization subroutine. So we got one that initializes the 0-page variables, one that initializes the interrupts, and one that loads the tile maps, and we've got something that resets the interrupts at the end. So after we do those ones in green, then we're going to convert all those bitmaps. So let's see here. Init, that was the one that sets all the 0-page values to 0. So let's go to that. I'm going to change the name of this. Okay, so now if we go back, I can change this name. So now this is our actual initialization subroutine here. First thing it does is calls initialization of the 0-page variables. Then it calls our initialization of our IRQ. Okay, and all that does is change the IRQ vector to our custom IRQ, which then goes to the normal IRQ vector when it's done recording the value of the Vera interrupt status register in our source bit. Okay, so let's see if we go back. The next thing it does is it loads the tile map, which is something we've had for a while, and then it calls iVer, which initializes Vera. And okay, so if we just go down here to initializing Vera, and for this we're going to need to pull up the Vera Programmer's Reference Guide. There's several things that we've got here besides horizontal scale. We will be changing the horizontal scale and vertical scale to 2.0 so that we've got a 160 by 120 screen. But before we do all that, first thing we're going to do is we set the value 01 in 0376. This is the character, the background color is the high nibble and the character color is the low nibble. So if we go to 0376 right now, you can see that it is set to 6.1. So that's white characters on a blue background. So we'll set it to white characters on a black background, or rather color index 0 on a background index of 0, which is black. So next we clear the layer 1 image with the, we're just loading the clear screen character and sending it to the kernel character out subroutine. Then we store 0 in our Vera control register. That's at 9F25 here. And all that does is make sure that we are selecting dataset 0. Okay, so then we load 01 into VVID. VVID is right here at 9F29. And so what that does is disables layer 0 and layer 1, while at the same time we still have VGA output mode. So both layers are going to be invisible right now. Then we load the horizontal scale and we store that at our scale variable that I just showed you a little while ago, and we load 20 and store it at horizontal scale and vertical scale. That gives us a 160 by 120 screen. Then we load the value 03 and we store that at Vera layer 0 control. So we got to go down a little ways here. Our Vera layer 0 config bit, that's what we've got right there. So we've stored 0 in the Vera layer 0 config bit, 03 in that bit, and all that means is now we have a map height of 32, we got a map width of 32, and we've got a color depth of 8 bits per pixel, and that we are not in bitmap mode, and T256C is irrelevant in this 8-bit per pixel tile mode. So next we got to set our layer 0 map base and tile base, and that's what we do right here. We set our map base to 4000 and we set our tile base to 8000. And this also sets our tile height and our tile width to 8. So if we just go back into here, so Vera layer 0 tile base, we've got 40 here. That means 80 is the start of our tiles, our tile data, and 0 here means tile height of 8 and a tile width of 8. Our map base we've got set at 4000 by setting 20 to Vera layer 0 map base. Next, we have set 0 in the Vera audio. Let me bring that up. The audio rate, we've set that to 0, and we have set 3F into the audio control. So that means we've got 16-bit in stereo, that's the 3 part, and F is our volume. We're going to have this as loud as possible. So until we change that sample rate, no audio will play. So next thing we want to do is so that's it for setting up Vera, for initializing Vera. If we go back, nope. If we go to init, our new initialization routine, so we've set the 0 page pointers to 0. We've set our we've initialized our IRQ vector. We've loaded our tile map. We've initialized Vera, and the last thing we have to do is clear tile 0. So we're using channel 0 in Vera. We set our address to 0080, and we have a step size of 1, and this is bank 0. And then all we do is we load 0 into the accumulator. We've got a counter here in Y, it's counting 64, and we just store that 0 in the accumulator into data 0 input on Vera. Decrement Y, and when Y reaches 0, we've done 64 of them, and that clears tile 0. So we've got all of our initialization done there. Now, to have our, what's left here? We've got our finalization subroutine. So the finalization subroutine for the interrupt is RIRQ. So all we need is a finalization subroutine for Vera. And if we go to RVER, that's what this is just resets Vera. Let's see. So loading A with 6.1 and storing it in 0376, that restores it to white characters on a blue background. Storing 0 in the Vera audio control means that we have turned the volume right down to 0. And I see I should insert 3 bytes here. And we will also set the audio rate to 0. Next, we load the value that we had stored in our scale and restore that into our horizontal scale and vertical scale. So right now it's set at 40 because I've got this at a 320 by 240 screen. But if we're calling this from a 640 by 480, we want that to restore as well. Then we clear the screen and we disable layer 0. We just have layer 1 enabled. So that takes care of that. So next we're going to convert the video. So the first thing we do is we call that initialization subroutine that we just did, and we enable both layer 0 and layer 1. Then we load our source file up, we convert the palette file, we convert the image file, and we load that image file up right away, and that will also increment the image file number. Then we go to the top of the screen on layer 1. We can actually print stuff on top of that layer. So we set our cursor to the top left corner and we load the palette high byte number and we call phex. Now phex is just down here. It's really simple. It calls cat-c, which I mentioned before, which converts the accumulator into 2 hex digits stored in X and Y. And then we just transfer X and to the accumulator and print it. We transfer Y to the accumulator and print it. So this basically up here just prints the prints the hex value that corresponds to the high byte of the palette pointer. Okay, I got that straight. Okay, so then we also load up the low byte of the palette pointer. We print that out as well. So at the top left-hand corner, when we are converting these files, there will be a hexadecimal number corresponding to the palette. Then we finally load the palette, and that will happen on a VSync, and we'll also increase the palette number. At that point, we increase the file number of the bitmap file, and we load the low byte of the palette number, and we compare that to the low byte of fini, which is the total number of files that we have to do. If it's not equal, then it goes all the way back here where it loads up the next file and repeats the process. If that low byte is equal to the low byte of fini, then it loads up the high byte of the palette, compares that to the high byte of fini, and if that is not equal, we're still not done. We go back and load up the next source file. If we are done, however, then we just reset our IRQ vectors and we jump to resetting Vera and we are done. So when we call xvid, that should convert all the palettes. And I am just about up at 15 minutes, so I am going to stop here after saving. And so we're going to do the conversion in the next video.